Okay, hello everyone. My name is Muhamad Fardil bin Abdul Rahman. My student number is 2022-972-851 and I'm from class F4CS230 for B. Alright, in this video, I'm going to talk and explain about ArrayList and LinkedList. So first, let's dive into ArrayList. Okay, what is ArrayList? ArrayList is a resizable array, which means it is dynamic. ArrayList can grow when you add element and it shrinks when you remove an element from the ArrayList. And ArrayList is a linear data structure. What does it mean by linear data structure? A linear data structure is a structure in which the elements are stored and arranged sequentially. Means that elements are stored one after another, and elements are connected to the previous and the next element. Okay. We can use ArrayList from the java.util package library, but in this case, we are going to create and use our own ArrayList class. Some of the common methods in ArrayList is add, which is to add data into the ArrayList, get to get data from the ArrayList, to set data, set, remove to remove data from ArrayList, and size, it returns the number of elements in the ArrayList. Okay, figure 1 shows here is a diagram of an ArrayList. In this example, the ArrayList stores integer type object, integer object type. To access the element in the ArrayList, we can use index. For example, to access the second element, we can use index 1. Alright, now move on to the next one, LinkedList. LinkedList is made up of nodes that contain the list items. A node consists of two parts, which is a data part that stores the element of the list, a link or next part, which stores the reference of the next node containing the next element. And LinkedList also is a linear data structure, same as ArrayList. LinkedList, same as ArrayList, can be found in java.util package library, but again, in our case, we are going to create and use our own LinkedList class. Some of the common methods in LinkedList is insert front, insert back, get first, get next. Okay, figure 2 shows a diagram of LinkedList. So you can see the first one, the first node is called head, and the last node is called tail. And every node contains a data part and a reference to the next node. Alright, now let's get to our code. Okay, first we'll see our ArrayList class. Okay, here it is. Now, in our ArrayList class, we have three properties: data property, length, and maximum size. And here we have default constructor, number constructor, and so other methods that we can use in our ArrayList class, such as maximum size, length, add to add object in the ArrayList, then to get object in the ArrayList, to set object in the ArrayList, to remove object, and all the other methods that you can use here. Alright. Okay, so here we also have ArrayList exception, in which this class extends runtime exception. Okay. We use this class in case there is an error that we need to throw. Can use that. Alright, now we have done with our ArrayList class. Now we move on to our LinkedList class. But before we can dive into LinkedList, let's first take a look at our node class. Alright, so this is our node class, and it has two properties called data and next. In here we have default constructor and two normal constructor. We have status here, and also we have getters, and last one is toString. Right, then let's take a look at our LinkedList class. Okay, so here we have in our LinkedList class we have three properties of node, which are called head, tail, and current. Alright. In here we have constructor, and then we have all other methods that we can use to interact with our LinkedList, such as insert front to insert data at the front of the LinkedList, insert back, get first to get data at the first place, to get data at the last place, get last, and also get next. Here we have remove also. Okay, and we also have an empty list exception for our LinkedList class. We will use this exception if our LinkedList class is empty. Alright. Now we have done with our data structure classes. We move on to our normal class. The first class that I want to show is vehicle class. So this vehicle class is a superclass, and it contains, or it has two subclasses called motorcycle and a car. But first, we take a look at our vehicle class. In vehicle class, we have three properties. The first one is vehicle name. The second one is plate name, plate number, and the last one is price. Then have here a default constructor, a normal constructor, a status, a getters, and also toString. Okay, and we move on to our first subclasses. First subclass called motorcycle. You can see here we use a keyword called extends, and it extends vehicle, right? And in this class we have only one property called has sidecar, and here we have default constructor, a normal constructor, and also we use keyword super here. And then we have setters, getters, here getters and toString. This class is just like a normal class. Also we move on to our next subclasses called car. Here we also use extend keyword and extend vehicle. And here we also have one property called num of doors, which is a number of doors. We have default constructor, a normal constructor, setters, getters, and the last one is toString. Alright. Okay, now let's get to our main class. First thing we do here is we import our scanner from java.ut package, because we need to use that to get inputs from user. And here we initialize a scanner object, and here we create a vehicle object, but we don't assign anything yet to the vehicle object. Here we create our array list called vehicle list, and we give the maximum size of 100 here. And then we have our linked list. Here we create two linked lists. The first one is vehicle more than average linked list. The second one is vehicle less than average linked list. Okay. Okay. Here we ask the user how many vehicle the user wants to input. Then we use that number for loop. And then we ask all the details that needs to be input. Okay. To create an object. Okay, here you can see that system.out.provide enter vehicle type, M for motorcycle and C for car. Here user can choose whether the user want to create a motorcycle or car. If the user chooses M, which means it stands for motorcycle, and then we are going to create a motorcycle and store it into our vehicle list. Okay, if the user choose C, which stands for car, and then we create a car and then store it in our array list vehicle list. Okay, and now here we have some properties: minimum price, maximum price, some min index, max index, vehicle index, and found. Okay, here you notice that enter vehicle name you want to search, so we store the vehicle name that user wants to search, and then we look through our array list. Okay, and then here you can see that we have two if statements. These if statements are used to check whether the object that gets returned from our array list is an instance of motorcycle, or if it is an instance of a car. Then if it is, we can class it to respective classes. Okay, then we can see here inside we check if the price of the motorcycle is more than maximum price, if the price is less than minimum price, and we check also if the vehicle name is the same as the vehicle name that user entered previously. Right, the operation here is the same. And as notice, we have sum, and we use concatenation operator to calculate the summary of all vehicle prices in our array list. Okay. And then once you have done with the loop, you can see that we create a new string, a double called average, and then we use sum and divide it with the number of elements in our array list to get the average prices of all vehicles. Okay, here for this one loop, here we check whether the object that gets returned from our array list is instance of motorcycle or car, and then if the price is more than average, if it is, we insert it to our vehicle more than average linked list. If it is not, we insert it into our vehicle less than average linked list. Right? So basically the operation is to move or copy our data from array list to linked list. And here we get to our output session. Here we display all the data and information that we have gathered and calculated, such as summary, the sum of our vehicle price, the average, and we use if statement here to check whether the vehicle name that the user entered previously exists or not, and if it exists, if found, we display the information. If not, we display that vehicle information are found, and then we display the minimum prices of all vehicles and also the information here, the maximum prices of vehicles and the information here. Right, here is something that is exciting. Traverse through linked list data structure with vehicle prices more than average. So here we use while loop to traverse through our linked list, right? In this case, we traverse through our more than average linked list. Okay. Then we display the data, and here also we traverse through LinkedList data structure with data with vehicle prices as an average. So we use while loop also to display the data. Alright, now let's run our application. Okay, so here you can see enter number of vehicle. Let's say you want to enter 5 vehicle. Okay, first enter vehicle name. I want to enter let's say LC135. And the plate number aka 4231. That's it. Vehicle prices is about 10,000 ringgit. 10,000 ringgit. Okay. Yeah, and it is a motorcycle, so we choose M. Does the motorcycle have sidecar? False, no. Alright. So next, I want to enter Activa. This is Activa. Plate number is ANM 1990. Vehicle prices is about 90,000. Let's say 90,000. Okay. And there is a car. Number of doors, 4 doors. Okay. And then next, enter vehicle name. Let's say Y15. Enter plate number. Let's say A2475. And then price, let's say 12,000 maybe. Okay, it's a motorcycle. Does the motorcycle have sidecar? False, no. Vehicle name. And now I want to enter maybe Saga, right? Saga. So enter plate number, let's say AML 9876. The price, let's say 46,000. 6,000 ringgit. And there's a car. Number of door 4. Okay, and then for the last one, let's say I want to choose R25. Okay. Plate number, let's say ALL 5656. Okay, price is maybe 20,000. 20,000. Okay, there's a motorcycle. That's 44, no? Okay, enter the vehicle you want to choose. Okay, I want to choose for Activa. Okay, enter. So let's say where's the output? Okay, here is the output. Alright, so the summary of all vehicle prices is 178,000. Okay, the average price of all vehicles is 35,600 ringgit. And okay, so vehicle information found. So I previously entered Activa. Then here you can find the information about Activa. Its vehicle name, plate number, price, and number of doors. So the minimum price of vehicle, which means the lowest price of vehicle, is 10,000, and the information about the lowest price of vehicle, C135. Okay, and then the maximum price of vehicle, 90,000 ringgit, 90,000 ringgit, right? So the maximum price vehicle information here, we display information. Activa, yes, it is correct, 90,000 ringgit, the most expensive price, the most expensive vehicles in our list. Now you can see that we traverse through LinkedList data with vehicle prices more than average. So let's see what's our average. Our average is 35,000, right? 35,600 ringgit. Then the one that should be in more than average is Activa and Saga. Yes, that's correct. Then traverse through LinkedList data with vehicle prices less than average. So less than average, it should be less than 35,600. So you can see that this is 10,000, correct? This is 10,000, correct? And this is 20,000, correct? Right? So this is our output. All the information. We have summary, average, minimum, maximum, and we have successfully copy and move data from ArrayList to LinkedList.